Let's solve few other examples of GWSSB paper. So for simply supported beam of span 10 meter, which of following ILD contains the maximum ordinate value as a 1. So we all know the influence line diagram for the support reactions is look like this. The ordinate is 1. This is your L. The influence line diagram for the shear force diagram that will look like this, and this ordinate value is nothing but L minus X by L, and influence line diagram for the this is your X by L, and influence line diagram for the bending moment at any section that will look like this, and this value is X into L minus X by L. So for these questions, our maximum ordinate as a 1, that is for influence line diagram for the support reaction. So this one is a correct answer. Yes, this is very important question. Point load P, and this question is related to influence line diagram, and for that let's see what is given. So point load P located at 3/4 of L. So this is your simply supported beam, and somewhere point P is located over here, and this distance is equals to 3/4 of L. This distance is 3/4 of L, and this distance is 1/4 of L. Now UDL shorter than this, so I'm going to draw one UDL over here, and the length of this UDL is that I'm going to consider is a small L1. This location is, this point is known as capital A1. This one is your B1. This is your A. This is your B. Moving on beam from left to right, maximum bending moment at P. So at P point पे हमें find करना है maximum bending moment. Will occurs when the UDL has crossed the point. So this point is, let's take this point as a P over here. So this distance is I am going to write down A, and this distance is I am going to write down B. So we have to find value of B. P point ની અંદર તમારે જે cross કરે છે, that you have to find out. So that you have to find out value of B. So you have to first of all understand the question. So now let's draw the bending moment diagram. So it will look like this. So maximum bending moment possibility થવા માટે શું જરૂરી છે? So these ordinates must be same. So I'm going to write down A1 and B B1. So to make maximum bending moment, these condition must be satisfied. A1 is equals to B B1. That's why for that A1 P divided by AP divided by PB, that is equals to A1P divided by PB1. So now you know the value of AP, that is 3/4 of L. You know the value of PB, that is 1/4 of L. That is equals to A1P, let's take it as a A, and PB1 that you can take as a L1 minus A. L1 minus A. So let's find out. This is going to be cancelled out, and your answer is A is equals to 3 times of L1 minus A. So A is equals to 3L1 minus 3A. So 4A is equals to 3L1. So A is equals to 3L1 divided by 4. So 3/4 of L1. So now you have to find value of B. So that B is equals to, what is B? B that is equals to PB1, and PB1 is nothing but L1 minus A. So your L1 minus 3/4 of L1. So you can easily calculate the value of this 1 minus 3/4. So that is equals to 1/4 of L1. So that's why your answer is 1/4 of its length. So it's really very important question, and like this way you can solve it. So 1/4 of its length. Now let's solve another question. Beam ABC has fixed the support at A. Beam ABC has a fixed support at A. A roller support at B. So this is your B, and fixed the free end at C. So at C free end is there. Length and flexure rigidity of AB and BC are same. So as per moment distribution method, what is the distribution factor for MBA at point B? So we have to find out moment distribution factor at this location. So this is a overhanging beam. So this one is a simply supported condition. That's why your distribution factor that is equals to directly 1. So your answer is D is equals to 1. Let's solve another example. Beam ABC B, C. Fix the support at A, roller at B, so I'm going to do roller at B, and free at C. Length of AB is 5 meter, length of BC is a 1 meter, UDL of W kilonewton per meter is acting on AB. So UDL is acting over here, that answer is 5 kilonewton per meter. And point load at C 10 kilonewton. So somewhere over here 10 kilonewton load is there. So moment MBA at point B, MBA. So over here is BA and over here is BC. So BA at point B towards span AB, that is equals to, so in moment distribution method, you know the internal locations, your moment value is equal but opposite sign. So over here your moment is equals to 10 into 1. So that's why your answer is 10 into 1. So that's why 10. So that's why for this span also your value of bending moment is also 10. That's why your answer of this is A is equals to 10. B is equals to 0 is a wrong option. Greater than 10 is also a wrong option, and depends on UDL, that also a wrong option. So you have only one choice. A is equals to 10 kilonewton into meter. So that's why this answer is A, 10 kilonewton per meter. Let's solve another example. Which of the following is not an example of the example of indeterminate structure? So fixed beam is an indeterminate structure. Continuous beam, it also indeterminate structure. Again I'm going to tell you which of the following is not an example of indeterminate structure. So amongst these all, this D option, it looks like this, overhanging on the both of the sides. So total number of reactions are only 2, and we have total number of equilibrium equation is 3. That's why this is the determinate structure. So our question, not an example of indeterminate structure. So this is a indeterminate structure. This one is also indeterminate structure. This one is also indeterminate structure. But this is your determinate structure. That's why our correct answer is D, beam overhanging on the both sides. Let's solve 42 example. So the second moment of inertia, so that is moment of inertia that we need to calculate. So moment of inertia of a semicircular arc, that we have to find out. So moment of inertia for semicircular arc, what is the equation of moment of inertia of the semicircular arc? Yes. So moment of inertia of semicircular arc, that is equals to let's say example of like this is your semicircle. Now first of all understand the equation. The second moment of semicircular area about its vertical centroidal axis. So this is your vertical centroidal axis. This is y. About this you have to find out. Centroidal axis having its horizontal as a base. Is over here D is a diameter and R is a radius. So this is your D and this is your radius R. So now what is the value of I? Suppose this one is your IXX and this is your I base. So I'm going to write down the equation for IXX. So that is 0.11 R raised to 4. But we have to calculate about YY axis. So I of YY, that is nothing but pi by 8 of R raised to 4, and that is equals to pi by 128 into D raised to 4. So your correct answer is pi by 128 into D raised to 4. And if they ask about the I of AB, then our answer is again pi by 128 into D raised to 4. Okay. Another question that can be asked like this: quadrantial circle is given, and if you want to find out the moment of inertia about its YY axis and about its XX axis, then and also about OA, then our equation is IXX is equals to IYY is equals to 0.055 R raised to 4, and IOA equals to OB, this is your OB, then your answer is pi by 16 R raised to 4. Please remember these two equations. This will be asked in the future examination. Okay, now let's solve another question. Bar AB of uniform cross section and the material throughout the length is material uniform cross section and material throughout the length is fixed at A. So one bar is given. It will look like this. This is like this. Uniformly throughout, material wise, section property wise, it's the same. So this is point A point per fixed hai. It's subjected to axial force P at the free end. So it is subjected to axial force P at the free end. B. So this one is your B. Simultaneously, another force of 100 Newton, internally 100 Newton is acting opposite to this P. So this is my 100 Newton. Force is acting of the bar. So what is the value of force P if delta B is equals to 0? Then what you have to do, you have to just go to the free body diagram. So over here, if P force is there, this is a tensile type of force, but at this location it will act like this, 100 minus P. 100 minus P is acting over here. Clear? So 100 minus P, if you combined it, this is also 100 minus P. So this is your tension and this is your compression. Now let's solve it. So sigma delta L is equals to PL over AE plus PL over AE. But over compression and tension is there. That's why P is same for both of the case. So PL first block is for a tension minus 100 minus P into L over AE. So let's take the common. So how we can determine it? So I'm writing down over here, somewhere over here. So I'm going to write down L over A is a common bracket, and that is equals to delta L is equals to 0. So 0 is equals to L over AE into P minus 100 plus P. So that's why this is equals to 2P minus 100, that is equals to 0 into L over AE. So from this, your value of 2P is equals to 100 and P is equals to 50. That's why your answer is 50 Newton. So this answer is 50 Newton. Let's solve another example. How many number of point of contraflexure are present for both side overhanging beam? Let's take this one is a simply supported and this one is a roller supported. For both side overhanging beam subjected to concentrated load, some load is over here, and if we have to neglect the self weight, that's why there is no UDL. This is your A point, this is your B point. So for that number of contraflexures that we have to find out. So you can see first of all shear force diagram. If any load is there here, then your shear force diagram will look like this. So it will not touch in span ની અંદર ક્યાંય જગ્યાએ તમારે 0 ને ટચ નથી થતો. That's why there is no point of contraflexures in this span. That's why your answer is 0. Let's solve another example. When subjected to UDL throughout the span, what is the ratio of maximum bending moment developed anywhere in the simply supported beam? So let's understand the question. Simply supported beam is given and UDL is given. Let's draw the bending moment diagram and value of maximum bending moment diagram, that you know, WL square by 8. Yes, simply supported beam. Then we have to find out ratio of maximum bending moment diagram of simply supported beam having UDL to the maximum bending moment. So second case is propped cantilever beam, developed anywhere in the propped cantilever beam. So this one is your propped cantilever beam and UDL is there. So the bending moment diagram of propped cantilever beam is look like this, and the bending moment diagram of simply supported beam having the UDL is this. So value of this value is WL square by 8. Clear? And this maximum bending moment at this location is equals to 9 divided by 128 WL square. So many people have made the mistake like WL square by 8 divided by 9 by 128 WL square. So this is wrong. What you have to do? They asked about the maximum bending moment anywhere. So our answer is maximum is WL square by 8 for simply supported B case, and this is for maximum for propped cantilever WL square by 8. So this cancel out. So your answer is 1. So your correct answer is 1. Let's solve another example. So over here, this is a shear force diagram given to you, and you have to find out the loading diagram. So how to determine the loading diagram for this kind of case? So for that, first of all, think about this. What are the reactions? સૌથી પહેલા આપણે reaction લખી દેવાના. So RA, you can see that is 90, and RB over here it is finished. So that's why RB is equals to 60. Then one by one you need to analyze that. So what you have to first of all see is this is a 90, and this inclined line indicates UDL. So in this case UDL is also there, over here UDL is also there, over UDL is UDL also there, over here is also UDL. Then there is a jump over here. So that means that over here point load is located. So let's see. So this point load is located. So possibility of this is also there, possibility of this is also there, but this is not possible. So again this is wrong. So this option is removed from our choice. This option is going to be removed. So now we have three options, A, B and C. Now let's total summation of RA and RB, RA plus RB, that is equals to 150. So over here, if you make the summation of all the loads WL, sigma W, then this 20 into 4 and plus 50. So 4 to the 80 plus 50. So total answer is, what is the answer? 130. So 130 is there, but over here our total summation is equals to 150. So that's why this option is also removed. Now we have only two choice. So for that, let's find out the reaction of this portion for B. So for B case, I'm going to rub this all. For B case, how to determine the reactions? For B case, we can find out the reaction for B option, that is sigma moment at A is equals to 0. So let's find out. RB into 10, that is equals to 24 into 4 into 2 plus 50 into because over here total reaction is 25 4s are 100 and plus 50, that's why 150 is there. So we have to analyze this section. Over here same way, total load is 150, that's why answer is from one of these, from two option. So 50 into 6, so that is equals to 200 plus 300 divided by 10. So RB is equals to, so RB is equals to 500 divided by 10. So that's why RB is equals to only 50. But our reaction is RB is equals to 60. That's why this option is also wrong option. So your correct answer is D. D is your correct answer. So your correct answer is D. Let's calculate for your interest. D is your correct answer. Let's find out the reaction. So RB into 10 as it is, that is equals to 25 into 4 into 2 plus 15 to 6 plus this moment is there. So 100 is moment is there, divided by 10. So RB. So RB is equals to, this is a 25, so 200 plus this is 300 and plus this is 100 divided by 10. So 600 divided by 10. So your answer is 60. That's why this one is 60 and total load mathi baad kari do એટલે RA is equals to 150 minus 60. That's why this is your 90. So this one is a correct answer. Thank you.